Hello. So today in class so far, we've been working with piecewise functions. You guys just saw some examples of real-world piecewise functions, and you started to practice writing formulas, or as we called them, function rules. For piecewise functions. So this video is going to kind of go through and formalize and explain exactly how to write formulas or function rules when you're given the graph of a piecewise function. What I recommend you have in front of you is this example. I also recommend that you have some your graph paper notebook or some blank graph paper, because when we get to a later problem, you're going to need some more room to write these examples. All right, number one, how would we write a formula for this piecewise function? So the general form of a piecewise function is, as you saw in class on Monday when you were given formulas, f of x equals, and then you normally have this weird bracket thing, something like that. And then essentially what we're going to have is equation, comma, a domain for that equation, and then we're going to have a second equation, comma, and then we're going to put the domain of that second equation. So let's go ahead and label all of those parts. First equation, second equation, domain, domain. All right, so what is this first equation that we have going on? Well, it looks like it's definitely a linear function, which is nice, because we just practiced writing equations of linear functions in the launch and in the discovery problems. So what is the y-intercept of this first equation? And what is the slope of this first equation are going to be the two main questions we want to ask ourselves. So there we go. We're writing the equation of the first line. And it's going to be something like y equals mx plus b. So we want to ask ourselves, what is the slope and what is the y-intercept? Well, the y-intercept clearly looks to be -3. It's the place where the function crosses the y-axis. So I know I can plug in -3 here. Question is, what is the slope? Well, I'm going to use rise over run. So I can see here it looks like the function's going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So the slope is definitely going to be 1. Question is it -1 or +1? Well, I want to ask myself, is the function decreasing? Meaning, is it going down from left to right? Or is it increasing? Is it going up from left to right? And it's clear the function is decreasing. So the slope is going to be -1. And then there's my equation. I'm going to make it look a little nicer because normally in math we wouldn't do like -1x. So we'd normally just say -x. We wouldn't say plus -3, we would just say -3. So there is my cleaned up version of my final equation for my first line. I'm going to go ahead and plug that into my function rule over here. My first equation belongs right there. All right, now my second equation, same process. This second line has a negative slope as well. And I run into this problem where I can't actually see the y-intercept of this second line. So when I'm trying to do y equals mx plus b, the slope is pretty easy. I can just see down 2 over 1, down 2 over 1, down 2 over 1. So it's clear that my slope is going to be -2. The function's decreasing or going down. Now, what is the y-intercept? Well, because it's a piecewise function, I can't see the whole function, but I can imagine if I continued the pattern of going over 1, up 2, over 1, up 2, what would my function actually look like? Well, it looks like it would cross the y-intercept. It would have a y-intercept at +3. So that is my equation for the second line. I had to do a little bit of extending the function because I couldn't see it. Alright, there's my second equation, -2x plus 3. Alright, so that was pretty much just, more or less algebra. I was writing a linear equation. Now comes the pre-calculus part, which is figuring out how to put it all together and define the domain of this first equation. So let me think for a second. What is the domain? It is going to have to do with the possible x values, or the x values that the function exists. So it's clear that I have something special going on at the x value of 1. This is the x value of 1. And it's a little bit hard to tell because I extended that second function. I'll just get rid of it. But at this x value of 1, I have this jump where I'm moving from my first function to my second function, my first line to my second line. So my first equation, I want to ask myself, does it exist for x values less than 1 or greater than 1? And it's going to be x values less than 1 because it's to the left of 1. And my function on the right, my second function, is going to exist for x values greater than 1. So the left, this domain would be x less than 1. On my right, this domain would be x greater than 1. Okay, so one last thing, I have to pay attention to the open circles and the closed circles. So the open circle is for the first equation. Okay, so that looks good. Open circle, it should be less than. But on my second function, my second line, I have a closed circle. So on this inequality, I should have a greater than or equals to. So I might go ahead and make a note of that this is because of the closed circle, and this is because of the open circle. Okay, this is your final function rule. I highly, highly encourage you to pause the video and try number 2 on your own, and then press play and check your work. Alright, welcome back. Number 2. We can start number 2, set it up exactly the same way. That's a weird bracket. We're going to have equation, domain, equation, domain. Let's start off with the equation of my first line. This one is nice and straightforward because it's just a horizontal line, and we know the equations of horizontal lines are always y equals something. In this case, it's going to be y equals -1, because if we imaginary extended this line out, it would intersect the y-axis at -1. So maybe make a note to yourself, that's just how you write the equation of a horizontal line. Second line gets a little bit more exciting because we have a y equals mx plus b. Okay, The y-intercept is going to be 4. The slope is 1, 1, 1, 1, 1, 1. The slope is 1. So we can just write that as x. And that is the equation of our second line. Okay, so first line is going to go there. There is my -1. Second line is going to go below x plus 4. So second line, first line, first line, first line. All right, so now I have to figure out the domain. I'm going to go in. It looks like in this case my special x value is -2. The function on the left exists for x values less than -2. And the function on the right is for x values greater than -2. Okay, now just pay attention to open and closed circles. Closed circle on my first function, it looks like, and then my second function has an open circle. So first function has a closed circle. I need to make sure I include the less than or equals to sign. Okay, so after completing 1 and 2 in your notes, what I actually recommend you do, a little bit weird, is to go to number 3 and actually take out your notebook. The reason I say this is because I just made the answer key for these problems, and I actually took up way more room than is on this page, if you can believe it. So I highly recommend opening your notebook and in your notebook completing number 3, so you don't get run out of room on your paper. I'm not going to draw this function just so this video is not a million years long, but you should definitely copy this function into your notebook before you take notes. Alright, so we have line 1, we have line 2. This problem is more challenging for our piecewise function because it's very unclear from the graph how we would find the y-intercept or the slope. So we're going to have to use more like algebra to figure out the y-intercept and the slope. We can't just use the graph. Okay, function rule is going to be the same. It's going to be f of x equals okay, so let's start to write our equation for our first line. Alright, so this is a line that passes through 2 points. That's pretty much all we know. It passes through 1, 3.5, and 3, 2.5. I'm going to go ahead and right away label x1, y1, x2, y2. So given 2 points, how am I going to write an equation in the form y equals mx plus b? Well, first I need a slope. I'm going to use our useful equation for slope, y2 minus y1 over x2 minus x1. I'm going to get 2.5 minus 3.5 over 3 minus 1. That gives me a -1. 3 minus 1 is 2. So I end up with -1/2 as my slope. Okay, so what happens now? Well, I know eventually I want to get y equals mx plus b. So what I'm going to do is say y equals -1/2 x plus b. and try to think about how I could solve for my y-intercept. So hopefully this process will sound familiar to you. What I'm going to do at this point in the problem is I'm going to plug in a point that I was given. So I'm going to choose the first one, why not? I'm going to plug in 1, 3.5. It actually doesn't matter which point you plug in, if you remember from Unit 1. You can plug in either point. And I'm going to get, this is my x value, this is my y value. So I'm going to plug in 3.5 for y and 1 for x plus b. And then from here, solve for b. 3.5 equals, I'm going to convert this to a decimal to make it easier. So negative 1/2 times 1 is going to be negative 0.5 plus b. I'm going to add 0.5 to both sides, and I get b is equal to 4. Ooh, good thing it's not a decimal. Okay, so now I have my y-intercept. I already found my slope way up here. I'm going to put it all together. The equation for my first line is y equals negative 1/2 x plus 4. Okay. So as you can see, this problem is pretty long and tedious because we're going to have to repeat the same process for the second line. However, it's actually not that challenging because a lot of it we already have talked about in Unit 1. So let's go ahead and do the same for the second line. I encourage you to pause the video and try it on your own, and then press play when you feel ready to check your work. Second line, back to my graph. What do I know about my second line? Well, my second line goes through points 5, 1, and 8, 7. Let's start by finding the slope. Once we find the slope, be 7 minus 1 over 8 minus 5 give us 6 over 3 gives us positive 2. We go ahead and plug that into our equation. Y equals 2x plus b. And then to solve for b, we're going to plug in a point. I'm going to do 5, 1. 5 is my x value, 1 is my y value. I have 1 equals 2 times 5 plus b, and I get b equals negative 9. Great, I have my slope, I have my y-intercept. Let's put it together. Y equals 2x minus 9 is the equation of my second line. All right, we are ready to put this all together into our function rule. So my first equation is going to go here. My first equation was negative 1/2 x plus 4. My second line was 2x minus 9. And now I just have to define the domain. All right, so the domain of this function is a little bit different because in our first two examples, we had these functions with like arrows, meaning they go forever to the left and forever to the right. So when we said the left side of the function was x values less than 1, we're saying it's like every single x value less than 1 all the way to infinity. For this one, it's a little bit different because we actually have like 2 dots. So we have more of a restricted domain. So I'm going to say for this first function, the domain is x is between, and there's 2 closed circles, so it's going to be 2 closed inequalities. X is between 1 and 3. And those come right from the points. From the x value of 1 to the x value of 3 is where this function exists. Same thing for the second one. X is between 2 closed inequalities, 5 and 8. Okay, that's a very long problem with many steps. You have a problem exactly like this on your problem set this week. What I'm going to ask you to do in class right now is to go to example 4. Example 4, where is it? Looks like this. There's an answer key, as you can see, and I've scanned this and posted it on the home page, so definitely open this up and use it as you work. I recommend doing this in your notebook. I definitely used extra graph paper so that you don't like try to squeeze all of your work onto one page. Again, these problems require you to go step by step and be really careful at each step that you are following through in order to find the equation of the first and the second line. So go ahead and try number 4 in your worked examples. Use this answer key, and then we will review number 5 later on as a class. All right, good luck, work hard.